In the last lessons, we talked about electrical fundamentals. We can apply them in our daily lives in several areas. First, the electricity bill. We can measure the cost of running an air conditioner for 1 hour. We look at the power rating written on it in kilowatts, multiply it by the number of hours, then we go to the electricity company's pricing and see how much it costs. So if we say, for example, we ran the air conditioner for 1 hour and the air conditioner's power is, say, 1 kilowatt per hour, we go to the electricity company's pricing and see the cost of 1 kilowatt. The cost might be, for example, 18 halalas per kilowatt. We can apply the same thing to other appliances. We look at their power per hour and multiply by the local electricity company's pricing. The second point we can learn from our previous lessons in our daily lives is that companies, before transmitting electricity, deliberately raise the voltage very high before the transmission process in order to reduce the resistance of the conducting wires, because they want to reduce the current that causes resistance. At the same time, they want to maintain the power, and power equals V times I, which is voltage times current. So if we're going to maintain P and reduce the current, we must raise V. Then, when the electricity reaches residential areas, we do a step down for the voltage. We lower it in the transformer and bring it close to the voltage used in residences, which is usually in the hundreds of volts. The third point, let's talk about heaters. In heaters, the final desired product is heat, unlike transmission in electricity companies, where the heat in the wires is waste or wasted energy. But in the case of the heater, the final desire is to obtain this heat. So now we do the opposite. We raise the current and then we place a material with very high resistance. This way, heat is produced for us from electricity. Of course, this heat is undesirable in the conducting wire. So to reduce its resistance, we increase the thickness of this conducting wire. The second point in our daily lives in wool clothing. When we wear wool clothes and walk on a carpet, for example, the friction process here is the energy we need to remove electrons from the wool atoms. The electrons transfer to the carpet and the carpet becomes negative and the wool becomes positive, and we get static electricity waiting for any conductor to discharge. One final additional point, how lightning occurs, which we'll talk about later when we discuss conductors. When a very high voltage difference forms between the clouds and the ground, even air, which is non-conductive, turns into a conductor. So the lightning process occurs, which is an instantaneous discharge of the charge. This point is very important when dealing with high voltage, especially inside factories or inside electricity companies, because a high rise in voltage difference between 2 points may turn air into a conductor. So we always find companies taking precautions against this phenomenon, which they call arcing, and placing it in their safety priorities.